Hi everybody, and welcome to the third video in section 4.1, Introduction to Probability. And here we're going to work on a couple more examples. Woohoo! So let's go ahead and get to it. So here we are. This is example 6. Yes, in the previous videos we've done 5 examples. And this is what we have here. We have a jar contains 60 red marbles, 45 blue marbles, and 35 yellow marbles. And what we're going to do is we are going to reach into the jar and choose one marble. Okay, so that's the experiment. We have this jar of these marbles. We are going to reach in and we are going to choose one marble. Okay, and the question here is, what is the size of the sample space? Well, before we can answer that, let's ask the actual question, which is, what is the sample space? The sample space is all of the marbles. Every marble represents an equally likely outcome. So what is the size of the sample space? Well, it's going to be the sum of all the marbles. So that is going to be 60 plus 45, which will give us 105, plus 35, which should give us 140. And that is the size of the sample space. Part B. What is the probability of choosing a red marble? I probably should have given myself a little more space here. Let's do this over here. The probability of choosing a red marble is going to be equal to the number of red marbles we have, because the event is pulling out a red marble, and there happens to be 60 of them, divided by the size of the sample space. So that will be 60 over 140, which reduces to 3/7. Both have common factors of 20. Or if you wanted to write this as a decimal, it would be 0.4286. Okay? And then next, what is the probability of choosing a blue or yellow marble? Okay? Well, the probability of choosing a blue or yellow marble, I'm going to call that the probability of BY, probability of BY. Sounds weird, but moving on. That's going to be the number of elements associated with either choosing a blue or a yellow marble divided by the total number of elements. That is going to be equal to 80 over 140, which we will reduce to 4/7. Both having common factors of 20 again, which as a decimal is going to be equal to 0.5714. Okay, so that takes care of example 6. Let's take a look at example 7. Here, we want to write out the sample space for a given experiment. Okay, we want to use the following letters to indicate the choice: white, W for white, B for blue, Y for yellow, C for charcoal, and T for tan, and G for green. And we are renovating our house, so we have a choice of paint colors for your game room: white, blue, or yellow. You can also have the following options to finish your entertainment center: charcoal, tan, or green. And they want us to write out the sample space. Now to do this, and since I don't have enough room to operate here, I'm going to need to rearrange my screen just a little bit. So bear with me 1 second. Okay, I am back. And here I'm out of my slideshow situation. So here's the slides, and here's a little place where I can work. Now notice that we are going to do the exact same thing that we did in example 4. We are going to create this tree for this situation. So let's get back to what we have here. Okay, and notice here, we are renovating our house, and we have a game room that we're going to renovate. And that game room can be one of 3 colors. Okay, it can either be white, it can either be blue, myself a little more room there, blue, or it can be yellow. Okay, so those are the 3 possible choices for our game room. We also have an entertainment center. I'm just going to call that an E center because, well, you know, I'm a professor, therefore I am lazy. My colleagues might take issue with me saying that. And we have 3 choices for the entertainment center. So my game room can be white, but then my entertainment center can either be charcoal, or it can be tan, or it can be green. So notice, what am I doing? I'm creating a tree again. My game room can be blue, but then my entertainment center can be charcoal, tan, or green. I'm beginning to sound like a broken record. And then finally, once again, charcoal, tan, and green. So what is my sample space going to look like? Well, I can determine that by just basically following down each branch of the tree. So I can either be white, charcoal, white, tan, white, green, blue, charcoal, blue, tan, it's supposed to be a T by the way, blue, green, yellow, charcoal, yellow, tan, and yellow, green. And if you get this question in your homework, which by the way you will, this is exactly how you would write it out. It would be WC, comma, WT, comma, and so forth. Now give me 1 second as I go back to my original configuration. Okay, I'm back, and here we are. And this is the last example that we are going to have for this particular video. And this is an example of classical probability. There are 600 balls in a box, and those balls are numbered 1 to 600, how appropriate. What is the probability of reaching into the box and drawing a number that is greater than 242? Well, the first question is, well, how many balls are going to have a number that is greater than 242? And the answer is going to be, I'm going to just write that as n, is going to be the difference between 600 and 242, which, by the way, would be 358. Now, how do I know that's actually the case? Well, let's just do a smaller case. Let's suppose I have a collection of balls that are numbered between 1 and 5. 1, 2, 3, 4, 5. And the question is, and let's just ask the question, well, how many balls are that are numbered between 1 and 5 or greater than 2? Okay, greater than 2. Well, there's 3, there's 4, there's 5. There's 3 of them. There are 3 balls that are greater than 2. And of course, how else can we find that? 5 minus 2 is equal to 3. Extending that logic to here, 600 minus 242 will give us 358. So it turns out n is 242. What is the size of our sample space? Well, there's 600 balls, so t is equal to 600. Okay, so the probability of reaching in and drawing a ball whose number is greater than 242, I'm just going to write that as p for the time being, is going to be n divided by t, or 358, divided by 242. No, I'm sorry, that is very wrong. 358 divided by 600. And of course, we have to reduce this fraction. There was a common factor there. And it turns out that this reduces to 179 over 179 300ths. And of course, you can also write that as a fraction, which would be 0.5967. And that is all that I have for this particular video. If you have any questions, please reach out and contact me. I will have 2 more videos. One will go over the law of large numbers, so we'll do a die experiment kind of illustrating that. And then another one will go over the homework. And until then, this is Bob Boyle, signing off.